Right everyone, welcome back to the video stepping through the derived grade chemistry exam for level 2 for TGC 2024. This is question 3 of the organic paper. First thing we need to do is draw 3 constitutional isomers with the molecular formula C5H12. So we want to go 5 carbons and single bond them, and then we just want to fill these all up because we've got to figure out first whether we need any double bonds or whether we've got the right number of hydrogens to do a saturated molecule. And looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this is what we're after. So I'm just going to name this, even though it doesn't ask me to, because it's one way that I can check that my isomers are actually isomers and I've not just drawn the same thing wonkily. So pentane, there's no functional groups I can move. So the only thing I can do to make isomers of this is to make branches. To make a branch, I have to make the chain shorter. So I'm going to make the chain down to 4 carbons and use the 5th carbon as a side chain. Notice I cannot put the side chain off 1 because if I do that, let's just have a quick look up here. If I did 4 plus 1, that is now pentane again. No, that's a common error. So this is now butane with a methyl group. So I'm going to put all my hydrogens in. And if I quickly name this, I will call it 2-methyl butane, which is a different name to pentane. Some of you might realise I don't need the 2, but I'm okay to put that in. Right, I can't move this to here. That's why I don't need the 2, because if I move the methyl group to this carbon, it would still be 2-methyl butane. I just number it from that end. And if I move it to either of the end ones, it makes it pentane. So let's reduce it down again to 3 carbons. And then let's put 1 methyl group here and 1 methyl group here. So if I put in all my H's, I've now got a propane. And I've got 2 methyl groups as side chains. I'll just quickly put my H's in here. H, 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 H. Right? And so I've now got dimethyl propane. Right, so that's my 3 constitutional isomers. They are saturated. So all molecules have carbon-carbon single bonds, which means they are saturated. So remembering that unsaturated, I don't know if we need to write this, but just in case, unsaturated means at least 1 double or triple bond. Right, we didn't have to do this one, but you will have to know this, so we're going to teach you this after exams, and this is our polymerization question. So polymerization always involves a carbon-carbon double bond. They do note in this question that they've drawn this benzene ring in, and you don't need to know what it is. It does not take part in the reaction, so we can just copy that. So we need to draw 2 repeating units. So remembering what we need to do, we need to take our monomer and we need to center it around the carbon-carbon double bond, right? So there's my carbon-carbon double bond. Copy the benzene ring in clumsily. That one's got an H on it, that one's got an H, and that one's got an H. So that's that copied. And what I want to do when I'm polymerizing is I want to break this double bond, right? And now each carbon's got space to make another bond. So this other bond is going to be used to join to an adjacent monomer. Right, and it only asked me for 2. So that's 1, that's 2, and I need to put my dot, dot, dots or some way to show that that chain carries on. Elaborate on the reaction forming polystyrene. So I need to define addition polymerization. So addition is where a C to C double bond is broken and 2 new, I'm going to define it slightly differently for polymerization, 2 new C to C single bonds form between adjacent monomers. Okay, so it is addition because we're breaking a carbon-carbon double bond and we're making new single bonds. But in this case, the new single bonds are made between this original monomer and its next door neighbour original monomer. Way back when we were doing addition on the other page, we were just adding 2 new atoms or atom groups on. Polymerization occurs when this addition reaction occurs multiple times with thousands of individual monomers to make a very long chain polymer. Okay, so I've kind of got the addition bit and the polymerization bit in there. Okay, so monomer and polymer I've kind of put in there. So individual monomers, so a monomer is an individual, sorry, is an individual molecule. In this case, an alkene that we use to form the polymer, which is a macromolecule, which is a long chain of joined monomers, something like that. Okay, so I've done that and I've done that. Compare the chemical reactivity. The monomer has a carbon-carbon double bond, which is highly reactive. So we know it can react with water, chlorine, bromine, HCl, HBr, etc. Whereas the polymer with all single bonds is very unreactive. This makes polymers suitable for uses involving storing water, food, etc. Doesn't really ask for that, but I'm just putting that in there so that when you read it, you can kind of have a little think about that yourself. And the last question on this paper is a long one, and it's a reaction question, and it's going to start with 1-chlorobutane, and it can react with KOH, and the organic product depends on whether it's KOH-AQ or KOH-ALK, and we have to compare these two reactions. So if you don't start like this, you're silly, because this will help you figure out what's going on. So we're going to draw this out. So that's my molecule, that's my 1-chlorobutane. I won't draw the H's in so this video doesn't go on. And I'm going to draw one reaction with KOH-AQ, and I'm going to draw the second reaction with KOH-ALK. So remember in chemistry to start with the equation, the reaction, the structure, anything to kind of focus your mind on what's actually happening. I do need to remember that in aqueous solutions, I've got K plus and OH minus, and then I'm going to get this substitution reaction here. So I'm still going to have 4 carbons, and I'm just going to swap the functional group OH for the functional group Cl. In this one, with my alcohol, it hasn't an alcohol, it can't dissociate into its ions, so it's just a catalyst, and this is going to be my elimination. So I'm going to still have 4 carbons, but I'm going to eliminate the functional group and a hydrogen from an adjacent carbon to form a double bond. Right, so there's my 2 reactions. So I have to do the type of reaction with a reason. the structural formula of the organic product. So I've already got my structural formula of the organic product. So I'm going to label these reaction 1, reaction 2. So I've just put a 1 and a 2 there. Reaction 1 is substitution, where the functional group, in this case Cl, is removed and replaced with an OH functional group. This happens when KOH is aqueous. Reaction 2 is elimination, where the functional group, which is a Cl, and a hydrogen atom from an adjacent carbon are removed, and a C to C double bond forms in their place. This happens when KOH is dissolved in alcohol. I think that's it. So maybe if it says compare, I might like to write a little statement. Both start with the same reagent, which is 1-chlorobutane and KOH, but the conditions, aqueous or alk, result in different reactions and products. Boom, tides. Right, there we are. That's the end of the organic exam, guys. I hope it went well for you, and if not, I hope you're going to learn something and aim to do better at the end of the year. I'll catch you later. Bye.